In our last lab, we introduced virtual local area networks, or VLANs. We used VLANs to separate traffic and to span one local area network or a subnetwork across two switches. And when we did that, the traffic from our student VLAN could not communicate with the faculty VLAN. So we were able to separate everything just fine, but nobody could communicate with each other. Well, very frequently we do need people on different VLANs to communicate. So to do that, we need to introduce Inter-VLAN routing. So Inter-VLAN, that's just between VLANs. We're going to use a technique today called router on a stick. Now we are going to router on a stick, that's what people know it as. It's 802.1q trunk-based Inter-VLAN routing is the official name. So you can see why people use router on a stick instead of 802.1q. It's just a lot easier to say. So let's get into it. I'm not going to reset anything. I'm going to cable my network. So again, just for ease of use, we're going to do this with just one switch, one router. We're going to stick two VLANs on this switch, VLAN 10 and VLAN 20. So we're going to simulate basically what we did in the last lab, but we're just going to do it all on one switch. Then we've got this router interface, G01 to G00, and we have some sub interfaces. There's some new notation in this diagram that we need to be aware of. We've got G0/0.10. That is a sub interface. We're basically splitting apart the G00 interface on the router into multiple parts so that that one physical connection can essentially pretend to be many different connections. We've got a loopback address. We've just got two PCs. Computer A is on VLAN 10, computer B is on VLAN 20. All right, let's get into it. So the lab tells me to cable the network according to the diagram. So I'm going to skip the console cables like always. I've got R1. I've got S1. I've got two generic PCs. So that's computer A. I'll put the IP address. We don't have that many IP addresses today. And it's default. I won't put the default gateway in. Oh well, it's an ugly label. We'll live with it. Here we go. Click on the right spot. Computer B. I'll put the carriage return, even though packet tracers doesn't honor that. All right, so that's all my equipment. Now I just need to cable it, so I'll click my lightning bolt. Fast Ethernet, so I'm going to F01. I'm going to connect this one to F024. And I'm going to go G01 on the switch to G00 on the router. Okay, looking good so far. Notice we do have one trunk relationship set up here. Remember what a trunk interface does? Think about it. Trunk line can carry VLAN tags. When a switch interface is defined as a trunk, the switch will broadcast the VLAN information with those Ethernet packets. So the first thing it wants us to do in this lab is to configure the client. So let's go ahead and do that. Click on computer A. I'll go another way you can set the IP address. Instead of coming to desktop, you can come to config and change the interface. I just like my way better. 10.10.10.10. subnet mask it recommends is not okay. So we gotta fix it. 10.10.10.1 for our default gateway. Close that. Bring up computer B. Here we are, 10.20.20.20. Change that subnet mask. 10.20.20. It should be .1 if we're using our normal conventions. Again, your default gateway is almost always going to be something .1. Okay, alliance are prepared. So should I be able to ping computer B from computer A? Ping 10.20.20.20. Yes or no? Pause the video if you need to figure it out. If not, here we go. No, it's not going to work. It's going to time out. So why can't computer A ping computer B? I haven't set up any VLANs. They're both on the same switch. I got green blinky lights. Green blinky lights means everything's supposed to be working, right? And it's not working. Well, they're on different subnetworks. And how do I know that? Well, I've got a /24 subnet mask, so that tells me that there are 3 octets that are 1s, which means the first 3 octets of my IP address define my network. So computer B is on 10.20.20, and computer A is on 10.10.10. So those do not match, so I know they're not on the same subnet. So they shouldn't be able to ping each other right now. Okay, for the switch, we're not going to do a whole lot. We're going to skip all that security stuff. Enable config T hostname S1. Now let's create our VLANs, and that's pretty straightforward. VLAN 10, give it a name. Uppercase, lowercase, doesn't matter. Student VLAN 20, name faculty. That name is just a friendly name for us to know what we're doing. Kind of like changing the host name of your switch or router. Now if we run do show VLAN BR for brief, I can see I've got those VLANs created, but no interfaces are assigned to them. Everything is assigned to VLAN 1 right now. So let's fix that, right? So we're going to assign the first 12 ports to VLAN 10 and the last 12 to VLAN 20. Int range, got to use that range keyword, F0/1 through 12, no spaces there. Switch port mode access, switch port access VLAN 10. So now if I run do show VLAN brief. Now, all those 12 interfaces are on VLAN 10, so that's good. So I'll do int range F0 13 through 24. The prompt doesn't change, but now I am configuring that those last 12 interfaces. Switch port mode access, switch port access VLAN 20. So do show VLAN brief. We're good. We've got 10 and VLAN 10 and VLAN 20. They've got a bunch of interfaces assigned to them. So now F024, so computer B will be connected to VLAN 20, and computer A is connected to VLAN 10. There's one thing to note, just to solidify in your mind. We define the VLANs on the switch. Computer A does not care what VLAN it is connected to. We never set the VLAN information on the individual laptop or computer or smartphone, anything like that. It's only the switches and routers and that kind of networking hardware that's hidden from our general users where that VLAN information really makes a difference. Okay, so now on the switch we are going to configure G01 as a trunk port. So it will forward the VLAN information, VLAN 10 or VLAN 20, up to the router. So int G01 switch port mode trunk. Easy as that. So I'm going to show VLAN brief again. Let's look at VLAN 1. It has 2 ports assigned to it when I ran it the last time. Do show VLAN brief. Oh, it's still there. Maybe because I haven't turned the router 1 on yet. Let's just keep going and see. Do show trunk. My gosh. Okay, I magically brought up my cheat guide because that command, I had a brain meltdown. Do show int trunk. Do show interfaces trunk. Oh my gosh, what am I doing wrong? Do and show int trunk. Okay. I don't know what I was doing wrong. Whatever. Oh, the command was right. There was just nothing there. Okay, we're going to keep going to see how the sausage is made, see how Dr. Margaretson screws up his commands occasionally. Okay, so can computer A ping computer B? Well, we already tried that. Let's just double check it still fails. Yeah, it's not working. Okay. Request timed out. Yeah, it's going to time out. Nope. So make sure you know why it's failing. Let's bring up our router. We don't need to add any serial connections here because we're just using the gigabit connection. So I don't need to turn that off or anything. I can come right to this command line interface. I do not want to continue with the configuration dialog. Let's look at what we need to do. So we'll enable conft hostname R1. So that's good. So we'll set the loopback interface. We'll just use that for ping testing, really. LO0. Change state to up. IP address 219.165.200.225. 255.255.255.224. Alright, so that's good. Now we are going to create the sub interfaces now on G00. So this is an important part. I'll use the command int G0/0.10. So usually if I did just G0/0, I would be configuring the main interface. But by putting in that period, I'm configuring the sub interface. Now here's something I need to do. Encapsulation.1Q10. Now this command tells the router that this interface should use VLAN 10 essentially. The switch tags every packet with VLAN 10 automatically. I have to tell my router that on this specific interface it should tag packets with that VLAN. Okay, now I'll give it the IP address like normal. 10.1.255.255.255.0. Now notice one command that I'm not running here is the no shut command. We'll do that in a second. But let's run the command int G0/0.20. And I could name these .55, .100, .99. It doesn't really matter, it's just we're keeping track of it. So we're going to assign VLAN 20 traffic to this sub interface. So it just makes sense to keep it consistent. Tab key is your friend. Tab key again. 20. IP address 10.20.20.1. 55.255.255.0. So that's good. So we're going to enable the G00 interface. So watch our blinky lights there. Int G00 no shut. Change state to up. So it'll take a second. So let's see. I'm curious now if I after this establishes its connection, will it actually show up as a trunked port. I configured that port as a trunk port, but when I ran show int trunk just 2 minutes ago, we saw nothing, right? Oh, but when I run it now, magically, it is showing up as a trunked port. If I say, I don't need the do command, show VLAN BR for brief, now G01 disappeared from VLAN 1. Okay? So just an interesting thing to be aware of. You know, this information will change as soon as you establish that connection. So good to know. All right, where are we in the lab? I'm going off script just a little bit. We did no shut, so we brought that up. Okay, we want to look at our router. We want to show the routing table. So I can run do show IP route. I need the do command because I'm in config mode. What have we got here? We've got the 10.10.10 network going through G0/0.10, and this other, the 20 network, through 0/0.2. Then I've got my loop back. Okay, so we don't need to set up OSPF. We don't need to set up static routing either. All this is just essentially a self-contained network. So everything is fine. So should computer A be able to ping the loop back address now? And can computer A ping computer B? Let's try it. First one might fail, I wonder. Let's see, timed out, then we get a reply. So I was right. The first one did fail, but if I run it again, it works basically instantly now. So that's good. So I couldn't ping computer B before, now I can ping computer B. So let's ping the loopback. Let's see if that works. Ping 209.165.200.225. That works. So I come to computer B, the ping should work. Ping, not pointing, ping 10.10.10.10, so that is computer A. Get a reply, that's great. Ping 209.165.200.225. Why am I doing pointing? I don't know. Bam. Get a reply, so that's working. So that's good. So if it's failed, need to troubleshoot. Okay, so what is actually going on? So why does this work? I'm going to add a text box here. We can just go look up at our network diagram. So when computer A tries to ping 10.20.20.20, where does it go? Well, it's not on the same subnet, so it's going to, computer A is going to try to send that to the default gateway, 10.10.10.1. So that's the IP address of the sub interface right there, G0/0.10. It's got the IP address 10.10.10.1. So it's going to send it to that router. Now, again, to ping an interface, to ping another computer, you've got to be on the same subnet and the same VLAN. If we didn't have VLAN information here, the ping would not be successful. So let's try something here. Let's come to our switch. Make sure we have selection mode. I'm going to go into config mode, terminal. And I'm going to go to int G01. So right now it's a trunk. We did switch port mode trunk. Switch port mode, let's change it to an access port. Do show int trunk. So now I have no trunk interfaces. Now let's just see. So we made a change to that interface, so it's going to renegotiate. So now that that switch is not going to forward VLAN information up to the router. So let's take a look. Computer A successfully pinged computer B previously. Let's take a look now. It's trying to ping 10.20.20.20. Not working. I changed this line from a trunk line to an access line. So an access line does not carry VLAN tag information to other network devices. Yeah, not working. So that's bad, right? It's very bad. Can I even ping 10.10.10.1? No. Computer A cannot even ping its default gateway. These are not, essentially not on the same VLAN. So computer A is on a different VLAN than G0/0.10. So it cannot even ping it. Because we're using VLANs, we have to make sure that that interface between the switch and the router is a trunk interface, or else it breaks. So on the switch, let's say switch port node trunk. Again, change state to up. How quickly will computer A be able to ping? So we'll see. Let's watch it. So it's trying, the ping is trying, but our switch is still talking to the router, trying to set that connection up. Timed out, timed out. We've still got an amber light there, so that's reasonable. Probably have to restart my ping again. Okay, all right, now it's working. Now I should be able to ping computer B again. It's all because we had to set that up as a trunk interface. So a key idea is that once you're using VLANs, to ping another computer on the same VLAN, you've got to be on the same subnet. You all have to be using VLANs. So that is very important. So let's come down. This should be good. We've done that. Okay, challenge time permitting. All right, let's do the challenge. Add a third VLAN to the switch to VLAN 30, name admin. So we need to assign ports 9 through 16 to VLAN 30. So think about how you do that. Int range F0 9-16 switch port access VLAN 30. So we were not using those ports previously. Nothing was plugged into them, so that's fine. So we'll add a third PC, PCC, what's its IP address? 10.30.30.30/24. Default gateway 30.1. All right, let's do that. Let's configure its IP address, 10.30.30.30. Change that to /24. All right, that should be good. We actually have to connect it to our switch. Connect it to interface 9. Okay, so nothing can probably ping that right now, right? My router knows nothing about that network. Ping 10.30.30.30. Yeah, that doesn't exist. Can't do it from computer A. I'll look at router 1. Do show IP route. It knows nothing about 10.30.30. Let's do int g0/0.30 encapsulation .1q30. So that matches the number on our switch. When we said VLAN 30, this is what we're matching here, .1q30. We need to give this an IP address, 10.30.30.30. 30.1 with the /24 subnet mask. Everything should work. Do show IP route. We've got the 30 network. Now my router knows about it, knows how to encapsulate it, meaning what VLAN information to tag it with. So let's bring up computer A again. This ping should work. Again, it might fail the first time, but then it'll start working. And so it was. The first one timed out, then we get a reply. If we run it again, they'll all work. They should all work from here on out. So that's good. Everything is good. Okay, so we've configured. So why is this called router on a stick? Well, this trunk interface between the switch and the router, that is the stick. It's just what it is. There's no better explanation as far as I know. Now, this is good. So now all PC A, B, and C, they can all communicate with each other. We've got VLANs defined on our switch, so that might help improve network performance, can separate traffic. On a router, maybe we could build in some security so that traffic from one VLAN couldn't access a specific one. There's stuff we could do on the router to do some more intelligent filtering or logging if we were worried about security. But overall, we're pretty good to go at this point. So one potential downside from using this method is that computers A, B, and C, anytime they need to go across a VLAN, all of that traffic for my entire network is going to go across the single interface, that Ethernet cable from the switch to the router and back again. So it's making a kind of an extra round trip that it doesn't seem like it really needs to make. So this router is going to be very busy just routing data between these computers. But it works. If you've just got a router and a switch, that's fine. If your network started to grow and expand, you would want to use some fancy devices if it comes to switches. We've got this 3560 switch here. Now, if you want to learn about this on your own time, that's fine. We're not really going to get into it too much in class. But this switch can also do some routing. So this is a multi-layer switch, or you could call it a layer 3 switch. A regular old switch, this 2960, it's a layer 2 device. A router is a layer 3 device. So layer 2 basically works with MAC addresses. Layer 3 devices work with IP addresses. So they work together to make everything run correctly. Well, this 3560 switch, it can do both. It can do layer 2 switching and layer 3 routing. So you could, in theory, replace this switch here, S1, with the 3560 switch, and you could configure that switch to do some basic routing so that you didn't have to send all your traffic to a router just to route between VLANs. That's just a brief introduction. In bigger networks, these are extremely common devices. They'll be all over the network. So as far as a submission, just take a screenshot of computer A pinging computer B, upload that, erase everything, put everything back, and you're good to go.